If you find these videos helpful, please consider supporting AddOhms and the Bald Engineer on Patreon. Hello, and welcome to a live stream. My name is James, and I'm the Bald Engineer. How are you doing tonight? In chat, if you can hear me okay, let me know your favorite component. Well then, I guess you can hear me. So, welcome to the stream. JFET op amps. Yes, those are actually pretty awesome. So, so tonight we are getting much closer to a not so temporary setup. Still not in the new lab, but that's coming soon. Frankly, I just didn't want to move my desktop computer down there because that's what I need to stream with. And so I decided to stay in the office transistor droid. And so anyway, getting closer. I want to say hello to everybody. Dr. J, I think for the first time in any of the streams we've done, you were the first person into chat. So welcome tonight. G-Bone, Babin, Geek Boy, Ross. Man, I don't know that I've seen your name for a while. Game Tech. Oh, did I give it everybody? If I missed your name, I apologize. I did not mean to. Okay, so what are we doing tonight? I've got this thing, which is called a Joulescope. It started out as a Kickstarter, which I backed, and I received one, but I have never hooked it up. And so it's supposed to be, they call it a DC energy analyzer. I don't know what those words mean, but I bought it because it measures current. And so I thought we would play around with it and see, how it works and what it does. Just want to mention, hashtag not sponsored, not endorsed. This was something I bought on my own, and I just thought it would be fun to play around with on stream. So with that said, I'm going to actually jump over to my computer because I haven't even downloaded the software for it, so we can actually get to do that together. And as soon as I did that, I lost my video feed. That is beautiful. See if that comes back. Man, you know what we're going to do? We are just not even going to try. Let's see, is this going to be long enough? Yeah, it's just the cable on my laptop is giving me trouble. Yeah, I think we're just going to swap it out. So while I'm doing that, why don't you guys in chat let me know what kind of projects and fun stuff have you been working on? Nope, that's not long enough. I thought I had another HDMI cable. That is definitely going to be long enough. And then while I'm thinking about it, I need to throw that one away because we're just not going to have this happen again. Okay. Okay, yeah, actually the stream feed is okay. It's the feed from my laptop, which you guys can't see yet. I was having trouble with that cable earlier, and I just knocked it and lost the picture. So I'm like, let's just change it. I don't want to be messing with it. Okay. Dr. J, you're drawing an 8086 motherboard. That's pretty cool. I would love to know how well that project goes, especially around creating the BIOS. You know, the old, I'll call it DOS BIOS, but the old PC BIOS, I never really fully understood it. I understood it from a user perspective and even a little bit of a programmer's perspective, but I never quite understood what it was, quote, doing. You know, like what were all the functions that were built into it. Bill says he's working on EMPs. That sounds dangerous. Ross is doing an oil pressure gauge for your car. Very cool. Game Tech is doing a custom Arduino board. What? Arduino board? I thought you only did Raspberry Pi stuff. I'm just kidding, man. I would like to know more about your NES game. I still have a desire to make a electronics-based NES or Commodore 64 game. I don't know what it's going to be, but I still want to make one. Yeah, so, all right, cool. Now, let's get over to my laptop. Let me fire up Firefox and make sure I don't have my bank account or anything like that open. I think we're in the clear, so I can switch this over to, let's go to laptop plus me. Okay, so now we're there. And why did Spotify decide to launch? That's interesting. Okay, so this is the Joulescope. So let's go to, people have asked what was the price. I don't even remember, it's been a while. So let's take a quick look at what they say it costs and what its features are and things like that. Okay, whoa. $7.99. I don't remember paying that. Hold on a second. I gotta go look at my email. That seems like it's not. I thought it was like $300. I don't have it here. Yeah, okay. Yeah, it was like $400. So they were not joking. This is okay. Well, this is going to be interesting because I did not realize how much these were. They, you know, like almost all Kickstarters will say, oh, we're giving you 50% off of the MSRP or whatever. Man, this is not what I expected to see. Because yeah, I paid like $4.99 or $449, like Empty Space just said. At least that's what my receipt was for. Which I thought at the time it was only $300, but that's what I get for not paying attention. Okay then, so it gives instantaneous values, views waveforms over time. Okay, we'll see about that. We can do it all on our computer. Low voltage drop. Okay. Well, we are going to test out as much of these things as many of these things as we can, because now I really want to know how well it works, being that it's affordable. I mean, on the flip side, depending on how accurate it is and how well it works, it could be significantly cheaper than, say, an oscilloscope and a current probe. But we're gonna have to see. Okay, let's look for a download link. Download for Windows. Yeah, great. Oh, I did not get my mouse. Shoot. Yeah, I agree. If it works well, it may actually be a good price. It seems a little bit high for something that measures current. But I don't, and I guess I should, before I make that judgment, we haven't even looked at like a data sheet for accuracy or anything like that. So maybe we should do that before we jump to conclusions. Is there a data sheet link? There's a guide. Dynamic range. Okay, but I wanted to know the number. So 25 millivolt at 1 amp. Okay. Let's see. Up to 15 volt, up to 3 amps. 1.5 nanoamp resolution. Okay. 250 kilohertz of bandwidth. I mean, that's not terrible for current, but I mean, with a lot of switching regulators running in the 200 kilohertz to 2 megahertz range, that kind of limits what you can really test with it. So, okay. So that $7.99 price was because it includes calibration, which, okay, that makes a little more sense. I mean, I don't know. I'm not trying to make a statement about whether or not it's worth it, but I understand why the price was so different. I'm confused as to why it has a bandwidth spec for current measurement though. So, I mean, even with current measurements, you still have a bandwidth associated with them. And so, you know, if you want to see if you want to see like what the rise time of transitions from low to high, low current to high current, then you'll want to have, you know, that's going to be affected by the bandwidth of the measurement system. And since most current measurement systems are basically just measuring the voltage of something like a shunt resistor or a Hall effect sensor, it basically comes down to whatever the bandwidth of the measurement system is. Okay. So, okay, here we go. This is more maybe what I was looking for. So it's got a bunch. Okay, so down to 18 microamps. Yeah, this bothers me. Only 256K bandwidth. I just feel like you're not going to get a really good. I guess what I'm thinking about is you're not going to be able to see any kind of harmonics from a switching power supply and the effect that it has. So from an energy consumption perspective, I guess that doesn't matter. I just feel like a little bit more bandwidth would allow you to account for that high frequency noise. Okay. Okay. I think it's downloaded now, so let's get it installed, see what happens when we do that. Yeah, definitely can't use it for any EMC testing, that's for sure. And in total fairness, they're not claiming it anyway. That's just us realizing, okay, based on its specs, what can you do or not do with it? Okay, let's launch it and see what happens. And I just realized, darn it, are you kidding me? Oh, cool. Okay, let's do this. Okay, software is up and running. Let me show you what I've got over here. Let's go this way. So here's the package that it comes in. Comes in a nice little case. Open up the case. Here's the actual instrument. And then there are, oh, I don't have a screwdriver. Well, that's a bummer. So then there are these front ends that allow you to measure either things with a banana jack, or there are different board styles. And I think one of them that I got was for USB devices, which I'm realizing now I may not have cables necessary to change some of these out. And then why do I don't know if this is an extra front panel, it looks the same. So, okay, so that's what's going on there. And then it did come with a USB cable, which I was about to bitch and moan that for the price they didn't include a USB cable, but it's in there and it's a nice one. So no need to get upset for that. What does this card tell us? Download the software, be safe, connect it, measure things. Okay. And then just for testing, I went and grabbed a few things. I've got a camera that needs to be charged, and then I've got a Raspberry Pi. I think this is a Pi 4. Yep, that's a Pi 4. So I thought we could maybe do an analysis of that. And then I also have my electronic load and a power supply. So plenty of things we can plug into it and see. The thing I just realized with the USB is I might have to run downstairs and get another USB cable. Because I don't want to unplug the only one that I have. But we'll worry about that later. Let's play around with some other stuff first. And it comes with a screwdriver. That's actually, I mean, okay. So again, sticker shock, now that that's wearing off. At first glance, the kit looks pretty nice. I think they've done a nice job. So, Dr. J, you're asking, there we go. You're asking about labels. So it has a CE label, and I forgot what this one, the FC label is. I don't think that's an FCC thing, but maybe it is, but I don't recognize that one. But at least has CE. I don't see anything about UL. And then over on the side, USB, as well as some GPIO. Okay, okay. Well, that's pretty cool so far. So let's, if those are recent certifications, there's your extra price. I mean, it's relatively recent. I mean, because this was a Kickstarter, everything, I mean, it was basically, since it was a Kickstarter, I'm pretty sure that part of the Kickstart was stuff like the licensing. Make a quick change to the screen. Okay, that works. And then we'll just move me over there. Okay. Mucho bettero. Although when I go to the laptop, this is probably going to be messed up again. Yeah, let me just make a quick change here, and then we'll get in. Then we'll connect it up and see what happens. Oh, I tell you what, guys, don't move. It is just non-stop. Oops. Okay. Yeah, I think they are not super pricey. I think for some reason, and this is totally on me and not them, but you know, when I picked this up, I just, oh, you can't see that. When I picked it up, I just, you know, to me, I'm like, oh yeah, this was like a couple $100. So it's just a little bit more than I was expecting, but I'm not actually, maybe, I think it was just a misplaced expectation. So, okay. Let's connect it up and see what happens to the software. So I'll plug in the USB cable there, and then I'll plug this into Mr. Laptop and see what it says. So 3 ways to plug in a USB: the right way, the wrong way, and then the first way again. All right, firmware update in progress. That sounds impressive. Let's move that over. Okay, can't move that while that's happening. Oops. I dislike how it did not ask. Yeah, it would have been nice just to make sure that, you know, hey, before you do something, are you ready for this? Okay, so let's see. We're connected to the device. It can be Okay, these are, looks like different modes. This is interesting. There is nothing connected to it right now. And it's picking up some form of noise. What are these traces? Let me see if we can. I wonder if it's measuring its own power supply, because like on the front of this, it has an input and an output. So maybe just the output is interfering with the input. So if I uncheck control, what does that change? Oh, I see. So this must be current, and then this one, this graph down here is voltage, and it's measuring 400 millivolts. Let's do this. I've got banana jack or banana cables, or do I? Uh-oh, I might not. Okay, well, I don't, but what I can do is I'm just going to connect, or I'm going to try and connect, basically short the input together just to see if that helps. Oh, are you kidding me? Well, that cable's not going to work. All right, so let's see what happens when we connect that together. Okay, so that looks a little more realistic now. I was touching the leads just now, and now I've got, I wanted to just run one wire between the two, but I didn't have that available. So what I ended up doing is I just have two leads, and I've just shorted them together. And so just doing that, it cleans it up, which, okay, that makes sense. It was measuring an open. It was just trying to make sense of noise. So not a big deal. That's, I think, understandable. Since there's a firmware update power cycle, okay, fair enough. Let's do that. Well, I tell you what, Dr. J, I hear what you're saying. Let's look at the other menu options, and then we'll power cycle it. So it has GPIO control. That may not seem like a big deal, but that's actually really nice when you're trying to test something, because that way you can basically set up the enable signals without having to do anything. Hey RJ, how you doing tonight? All right, so it looks like you can have the scope and multimeter at the same time. This is giving me kind of a vibe like the what do you call it? The Analog Discovery 2. Okay, and then what I'm not sure I see yet though is it has an output. So where do we control the output? Let's control current range auto. Or is this it? Can I only output 5 or 15 volts? That's kind of... Okay. Which, I don't know, maybe that's okay. Okay. I'm reading it, it's like a pass-through device. Oh, I see what you're saying. So we'll hook up input from our power supply, and then out goes into the other thing. And then for control, we can actually tell it which range we want. Okay, that makes more sense. That makes more sense. Okay, so let me think. What I just realized is one of the cables I have is busted. So what's going to be our best bet for hooking this up? I think either let's see, because okay, what I'm realizing is I think I need 2 different cables and I don't have an option for either one of them nearby. So tell you what, I'm gonna put up the be right back. I'm gonna run downstairs where my cables are and see if I can grab another set of banana cables. I hope I can find some, and then we'll set that up. And if I can't find that, I will grab another USB cable so that I can plug in the USB adapter, because then we can at least play with the USB devices. So yeah, so I will be. Well, yeah, the problem with the alligator clips that I have is, where did I put it? Is, that I broke it. So my one lead, because that's what I thought I was going to use, but my one lead is missing the banana jack. So, and these are not screw terminal types. So let me go see if I can find another cable, and I'll grab another USB cable because I need that anyway, and then we can keep moving. So, okay, yeah, it doesn't look like this twist. Yeah, that's a bummer. Okay, I'll be right back. Let's go. Okay, good luck, or good news, not good luck. I found everything we need. So I have a USB-A cable and, excuse me, and proper banana jacks. So now we just need stuff to power, and I even have an Arduino, so let's start there. So what we'll do is I have my portable power supply. So let's get this set up. You're not excused. Okay, fine. And we'll plug this in and plug this in. And then we're going to go from, so we're set to 5 volts there. So then we're going to go into the input of this thing. And then there's the banana jack I was missing. I'll put these out of the way. Okay, so now let's grab these. I want this cable. You know, the really sad thing is it probably seems like I'm really disorganized and everything right now, but my desk is relatively clean compared to what it normally is. And I was actually even just now thinking, it's really nice that it's so easy to find everything I need. Which makes me wonder why I have so much stuff in all the other boxes that I haven't opened yet. Okay. So I've got the Arduino is hooked up on the 5 volt pin. We should really actually put that on VN. And that's totally bad. Oh, that's why. Here's what we're going to put this on VN. Oh, this will be a fun thing. Let's compare the power consumption of an Arduino board by itself when you go from, say, 9 volts to 12 volts. Okay, so we got that on the VN, and then on my power supply, I will set this to be 9 volts. And it's set for 9.1, that's fine. We're gonna go with that. So plus, 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 minus, minus, and then VN and ground, okay? Now all you need is a crimp tool. Yeah, no kidding. Finding things is a relative term. Yeah, I know. So a friend of mine recommended, you know, these tiles are really great because you can put them in all your like components boxes and then you'll know where they are. And I was like, okay, well, how many do you have? He's like, oh, I've got so many. I've got like 10 or 12, but they still work. I was like, yeah, I've got one row or one shelf of boxes and there's 20 and then multiple shelves. So I was like, yeah, I don't think tiles are going to work. Okay. So let's switch to the laptop and maybe this one. Yeah, we'll do that one. Well, we'll do this one in case the blue smoke gets let out. Turn this on, and then the power supply says it is drawing about 50 milliamps, which is what you would expect for an Arduino Uno. So that's looking good. And then what do we see in the software? So let me see, if I make this bigger, do the numbers get bigger? Not really. Okay. So we see 56.5 milliamps at 9.1 volts. Okay. 5.51 milliwatts. Oh, that's cool. 15 joules. Okay. That's not insignificant. That's pretty interesting. Okay. What I wanted to check is since the power supply tells me that it's doing 56 milliamps and the Joulescope says 56 milliamps, I'm not going to verify that. I'm going to say, yeah, that's probably a valid number, but I am going to do my best to measure voltage real quick. And so I don't know that I'm going to be able to get this in the shot. but I'm just going to measure the voltage like here because I don't want to short anything out. And I'm measuring 9.09 volts on my meter. Joulescope is measuring a little bit higher, but it seems to have more digits of precision. So maybe it's just a matter of precision, which is why those are off. But they're also, I mean, we're talking like 10 millivolts of difference. So, okay. So this is the multimeter mode. And a couple of you have already kind of hinted, don't like this mode. So let's go to oscilloscope and turn the multimeter off. Okay, and then let's turn the, where was the single value? Well, that's on. Oh, uh-oh. Or do we just close these and that goes away? Okay. Totally makes sense. So what are we actually looking at then? If we add a marker, does that really help? That actually, I kind of like that better. So up here, we're measuring 56 milliamps, min and max, peak to peak. Is that sigma? Yeah. So down here is 9.106, min and max. Man, you know, oh, I should have had my scope. Should have brought my scope up. Maybe on break I'll get my scope and then we can actually see. Is that DC? I mean, it's a DC source, but you have to remember there's, other than batteries, there's really no such thing as a pure DC source. They all have some amount of noise, so they all have some AC component associated with them. So we're actually not building anything in today's stream. Today we are looking at this this device called a Joulescope. Let me just show you what it looks like real quick. So it's this guy. And so what we've got is my power supply is connected to its input. And then on the output goes to my Arduino Uno. And that's what we're looking at on the screen here is the output from the software. And let's see if I just move this over a little bit so you guys can see the numbers better. The yellow part looks like a clock signal. Okay, you know what we could do? I got an idea. Let's see how sensitive this is because we've got the onboard LED. So let's program the LED to blink on and off and see if we can see the blink rate on the current. So DC is dirty as hell. Yeah, I mean, yeah. This bench supply is a switch mode supply, and I think for a switch mode supply, it's pretty good. But for a actual like bench supply, it's somewhat noisy. But that, given its size, can't really expect that much out of it. All right, so let's fire up Arduino. I'll just use Arduino today. I'm not going to bother with Sublime. I'm an electrical engineer, or I prefer to say my background is electrical engineering. I always struggle, is it electrical or electronics? But I don't play with AC, I'll put it that way. Okay, we got this. Let's go to new, let's open up a new one, tools. I'm still set up for Sublime. Let's kill that. Hey, is it Hato Line? Thanks for the follow. Welcome to the stream. Let's do undo use external editor. Man, I'm just drinking tea tonight and can't talk. So our board is going to be a Uno. Where are you at? Where are you at? And, oh man, when I went downstairs, I should have grabbed my mouse. AC is pretty elementary once you get used to it. Yeah, actually, it's actually, I think, pretty simple to understand, but it's also dangerous, or orders of magnitude more dangerous than playing around with like 5-volt DC circuits, and so I just don't like to mess with it. Okay, so let's do a quick pin mode, 13 output. And because I am the way I am, unsigned long, previous millis, unsigned long, blink interval, and Boolean LED state. So then we're going to do unsigned long. Oh, and let's go ahead and do const unsigned long blink interval equal 1000, and then up here we'll do const byte LED pin equal to 13. And then down here we can do unsigned long current millis is equal to millis if current millis minus previous millis is greater than blink interval. Then we want to reset the clock. And then we want to change the state of LED state to equal to the opposite of LED state. And then we'll do digital write LED, oh no, LED pin, LED state. Beautiful. Save that. That's good enough. Humans are just variable impedance transmission lines. Yes, we are. But we do make for fun TDR graphs. Saul is asking, how long did it take you to figure out how to use an Arduino? Well, I'm not trying to be conceited when I say this, but it took me about 15 minutes because I had a background in embedded programming or embedded controller programming. And for the 8051, I used to have a library that was very much like the Arduino library, where I had like, I didn't, my function names weren't nearly as clever, but it was like, because it was like set pin to input, set pin to output instead of one function that does both. And so I got it. It was very easy for me to pick up because I had a background in embedded programming already. So, okay, I'm looking at my LED. It's blinking at once per second. So now and holy cow, we already can see this. Check that out. So we can actually see how the current is changing when the LED blinks on and off. That's okay. That's pretty cool. That is pretty cool. If I hit this, does it stop? Yeah. Or no, that's record. I don't remember. If I hit this, does it stop? Yeah. Okay. Well, that's pretty cool. And then I don't know how to move the markers. Doesn't look like. I can't just click on it and move it, so I don't know how to use them. I wanted to put one to see so we could see what the min and max were. But if the current is changing by about 5 milliamps, that makes sense because the LED has I think a 1K resistor. So yeah, a couple milliamps difference of when the LED is on and off. Why does it look like 3 signals? I'm not certain what all these waveforms are, and I don't see like a clear legend for what we're actually measuring. If I had to guess just off the top of my head, this could actually be maybe the positive, the negative, and then this is the differential. But yeah, that's something I'm not fully understanding is what all 3 are. Measure. Oh, it says right click. So let's try adding this again. If I right click, no. Okay. I'm not getting how the mouse works. Because it has N0 and N1, so I wonder. Yeah, I know, right? I don't know why they don't just have... I hate when that happens. It's like, come on. So, what are we looking at? Theory of operation, host software, oscilloscope view. Okay. Two different waveforms. The top waveform is current. The bottom waveform is voltage. Yeah, I got that far. Okay, the y-axis, 2 million, yep. Okay, the min and max ensures you don't miss these events. So, oh, the yellow line is the average. Okay, I missed it. The yellow line is the average, the red is min and max. Okay, so that's the average, that's min, and that's max. Is there a way to... I don't see a way to turn that off. Oh, here we go. That's a little bit easier to read. Okay. Okay, turn this back on. It's interesting with the higher with the better scale, we can actually see how there's like the tail when the LED turns on and off. So, okay, let me just make sure. All right, so now let's just see what, let's just get an idea how good this is. So let's change it to 250 and upload that and see what that looks like. That's so cool. You can actually see what the power consumption looks like. This was the programming cycle right here. And it looks like, because we're on for the current range, we're on auto. So it looks like it's like changing the y-axis based on how much current is being drawn. Top has min, average, max, and same for the bottom. Yep. Yeah, so, and then this waveform up here, just to reiterate, so this waveform up here is the current, down here is the voltage, and so since I don't think there's enough of a voltage variation, what we're probably actually measuring down on the voltage is the output variation of the power supply. In fact, when I did a review, did I do a review or a, yeah, I did a review of this Tenma portable power supply, and when I looked at it on my oscilloscope, it actually had like, I want to say up to 100 millivolts of noise when fully loaded. At low currents, it was pretty low, but like I said, relative to a bench supply, it's very noisy. But for a portable supply like this, the size of a multimeter, it's actually pretty good. So anyway, so there we go. So we can actually see the blink rate of the LED just by looking at that. Now, Geek Boy did ask for, he wanted to see the surge. So let's try this. What happens when I turn my power supply off? Okay. Yeah, inrush current. That's what you're. And I'll turn the supply on. Well, that just kind of happens too fast. So let's stop it. And yeah, I don't like how I can't. Oh, that's why I couldn't. Okay. So that's kind of cool. So let's think about what we see here. Why is this sitting at 4.2 volts? Comes down to practically 0 and then goes back up to 9. I don't know that that makes sense to me. So let's turn it off. Well, that doesn't look right. Okay. And then we'll turn the supply on. And now we'll stop it and then start doing a zoom in so we can see what this looks like. Whoa, that was, I feel like that's not, I feel like I'm missing like a level of zoom there. So it's practically zero. This voltage is bothering me because I don't think this is scaling over here. Why negative? I actually know what that is about. The negative is actually, it's an issue with the power supply. It doesn't actually go all the way to 0 volts, and so you'll actually see a little bit of negative current whenever it's off. And so I don't really know what's going on there. Is there going to be a Joulescope giveaway? Nope. This is not a sponsored or endorsed stream. I bought this myself and we're just taking a look at it. And so I have no plans of giving mine away. So I want to see if we can, I want to stay like zoomed in. Okay, I'm going to turn this off and then stop it because I want to see what it, man, that must be a bug. Oh, I know what's going on. It's rescaling because it loses the, okay, it loses this data over here, so it rescales. Okay, so this is claiming right now, let me double check this. What? It's still on. Well, I didn't expect that. So the Arduino is on and blinking, even though my power supply is off. So I'm gonna disconnect the power supply and the Arduino stays on. Oh my God. Yeah, I can't believe I just did that. Yeah, it's because we're connected by USB. Well, this really measured it correctly. Oh goodness, that was so silly. Okay, so I totally had a brain fart because I connected the Arduino to USB so that we could program it and change the blink rate. When we turned off the power supply, the onboard selector switched over to USB, which is why we saw the signal sitting around 4 volts or whatever. Okay, brilliant. Okay, so let me plug the supply back in. Supply is still in the off state. So now we're seeing like, yeah, so basically if we just look at the scale over here, we're seeing basically 0 volts. Okay, so let me turn this on and then we can, okay. Ah, I hit the wrong button. Okay, let's turn it off. And then we'll turn it on and stop. So now when we zoom in, oh, check that out. So we see almost like a Miller effect kind of thing, right? So the voltage ramps up nice and clean, or relatively clean. And then current comes up, kind of dips for a little bit. So I wonder, let's see, we are powering, what are we doing? We're powering 9 volts going into the regulator. So I'll bet what's going on here is the regulator starts to turn on, and then it probably does a current limit because the input capacitor is charged too fast. So this is probably the decoupling cap's charging up. and then the regulator probably slowed down the charge, and then it opened it back up, and then it came back up, and then this is probably the first time the LED blinks. That's my guess, just because there's a pretty big change there. Or maybe this is when the micro finally gets active and going. Well, that's pretty cool. I think this is pretty cool because, so I work for Rohde & Schwartz, and we have this box about the size of the Joulescope. Now it has like 8 channels on it and samples much faster, but it can do this kind of measurement. And I mean, it's like an order of magnitude more expensive. So, you know, again, I feel really bad for kind of having the sticker shock of this being a $400 tool, because I'm starting to understand why it is. I mean, it's not just the DMM. So now let's see, because I was having trouble with the markers. So I want to figure out how to move the markers around. And maybe there's like a, what's the point of having markers if they don't move? Is there a window for the markers? No. Let's see what's in preferences. Device. Okay, oh, that looks good. I don't know what that is. Oh, GPIO. Multimeter. Okay, I hate to do this, but we're going to have to look at the manual again, because I'm not understanding how to move the markers. And did they call them markers? Yeah. All right, so just do marker. So displays information at a single point. To move the marker in the x-axis, move the mouse to the x-axis time labels near the top. Then right click, select annotation, single marker. Left click, okay. Nope. Annotations, single marker. Oh, I see. So I guess I have to like, can I do it here? Annotation, dual marker. Nope. That doesn't do what I want at all. Okay, let's clear them. This is really awkward. Why can't I just grab the marker and put it where I want? Annotation, single marker. And then I guess this, because this just to me kind of is like, it limits the, yeah, see, but that's still not what I want. I want, yeah, no, that's not what I want. Okay, well, okay. Yeah, this isn't how they work though. Left click the, what? Display this, right click, annotations, left click a marker to move it with the mouse, then left click again to stop the mark. That's not how it works. Annotation, dual marker. Yeah, I can't, okay. Well, I wonder if there's a bad interaction with my, with the trackpad, because I know sometimes some applications get confused by that in Windows. I don't know. Okay, that sucks, because I wanted to put a marker here and a marker here so that we could see what the time difference is, but it doesn't look like the software lets you do that. So it would have been nice if it just told us the delta between these two markers, but that doesn't look like, yeah, we'd have to calculate it ourselves. When clicking on the marker, don't hold down the mouse button. I don't know, there's like, or maybe I'll try holding it down. Nope. So I'm doing annotation, and then I'm just clicking one time for dual markers, and now I can't do anything. And now I can't do that. If I click, oh my. Okay. Dr. J wins. Thank you. So our delta time was 13.8 milliseconds. That's pretty cool. Oh, I'm out of USB cables. Otherwise, we could actually do it over USB and see how long it takes. But, oh, wait, I burnt my box. Does this box have one? Nope. Nope. Okay. Tell you what, let's do something else. Let's move on and look at something else. Let's switch over. Oh, I don't have a. Why does everything need a cable? No, I brought one of those. Okay, I was gonna say I've got. I just happen to have an analog discovery with me. So what I just want to take. Let's just do a quick look and see what it looks like in terms of power consumption. But to do that, we're going to need to switch the faceplates of the Joulescope. So let's do that now. And we may even, let's see if we can take it apart a little bit. Okay, so undo those power connections, bring this back out, unplug that. Let's just put this in the magic box. I'm going to steal that, Dr. J. Most would call my boxes of boxes junk. I call it engineering tools. Yeah, that is what I call it as well. Okay, so let's see what happens when we try to replace these faceplates. Man, I did not position that camera well at all. It seemed like such a good place when I did this earlier. Oh man, that is on there. Oh, oh yeah. Okay, next. Oh man. Well, these weren't going to come off accidentally, that's for sure. Well, that was the easiest teardown I've ever done. Oh. Okay. Let's do this. I'm going to zoom in and then let this get a good, I'll even put it down so maybe it has a chance to capture that nice and clean. There we go. Let's get it to right about here. And then let me do this real quick. And, oh, can somebody grab a screenshot? I can't hit the button. But yeah, anyway, what I was going to try to do is like open up a screenshot of it, and I'm not sure that's going to even work out. So this looks like so what do we got? So this is a NXP chip and LPC microcontroller. And then over here is a nice, let's probably some kind of coil, maybe a transformer. And I'm just wondering because it looks like there's a decent amount of isolation that's occurring between the digital stuff and the actual measurement side. Let's see. So on the measurement side, there's looks like an STM32, and then I see I don't know what this is. It's a lattice. Oh, it's a lattice ice chip. So over here is an STM, and then over here is a lattice. I don't know if it's an FPGA or a CPLD, but I think it says ice on it. It looks like the lattice logo. Same thing with this one up here. What I'm not seeing is I expected to see a big ass shunt resistor. Okay, just a note is on the back. It actually has silk screen that says USB host, and then over here is sensors isolated. And you can actually clearly see the isolation between the two halves of the board. So I think that's pretty cool, or pretty well done, I should say. So, but yeah, I've looked at this for all of 10 seconds, but I'm not seeing like a sense resistor. So I wonder what it's doing. I wonder if it's just like measuring it through a FET or something. Does it contain a Xilinx chip? It doesn't contain a Xilinx, but it does have 2 lattice chips. I think the logo looks like lattice, and I think it says ICE. I have my phone on me. I don't have my phone. I'm gonna wash this out for just a second so I can see it. Yeah, it looks like ICE 5LP2X. I feel like I'm at the eye doctor. Or ICE LP2X something. Yeah, so there's 2 lattice parts on either side. And then looks like optocouplers and such, transformers to do the isolation. But yeah, I just don't see. I thought we'd see like a current sense. I wonder what it's doing. We'll have to look at that in more detail at some point. Okay. How do I share my screenshot? I would have said share it in the Discord, but now that I sort of went through it, there's not really, don't worry about the screenshot, because I basically, so there's an NXP microcontroller, which is mostly there for the USB host support. There's an STM32 over here, which is probably controlling the measurement side. And then each side looks like a lattice FPGA or CPLD. And then all this stuff up here is for the measurements. And then on the back, there's basically nothing. It's all the stuff is on one side. So yeah, maybe at some point I'll give it a closer look and try to get all the smaller analogs. Because sometimes if I can get the analog parts, then I can kind of tell what the different filtering circuits are doing. So I think this plugs in like this, and then this just goes back into here. And that is totally the wrong way. Well, that's not going to work either, because I totally did this backwards. All right. So I just snapped, so now that you guys can see, I just snapped the board on. And then we'll slide this guy back in here. Now this is interesting. It only uses 2 of the 4 screws. I don't think we're going to put them in as tight, because I don't think I'm that strong. Not for a philosophical reason. All right, got that. And then we'll do this one over here. There's a sense resistor on the front panel. I'll take a closer. Man, this doesn't seem like. Oh, this isn't in right. That's why this is feeling funny. I did something wrong. On camera distraction. So after I put this together, I'll show you one of these panels a little bit closer so that you can see. Maybe just the panels themselves are the actual sense resistors. You know, maybe they use like a precision PCB manufacturing process. Yeah, I totally missed the slot on that. Good job. Okay, that looks better. So maybe just the resistance of the traces themselves are the built-in sense resistor. Which I guess it would make more sense to have the sense on the panel than go to the board and back. I'm thinking there's an FPGA or CPLD. Yeah, I think those two lattice parts are FPGAs. But I mean, so it's on both sides have microcontrollers, which doesn't surprise me, and then probably FPGAs, which is probably the firmware we saw that got flashed when we plugged it in. So yeah, so if we look at this panel and make it a little brighter. Focus, focus, focus. So, whoa, what happened to my light? So, what I wonder is, I can actually see, I don't know if it's showing up in the camera, but if you look, there's like this, there's clearly like a ring around here. And so I wonder if like maybe this is a heat sink or something. But like I don't see like a resistor, so I wonder if it's just like embedded in the substrate itself, or they just said, okay, let's make a big trace, and that trace becomes our resistance. And so this panel does the same thing. It has like a, maybe if I hold it right here, you can see how it has like a, or maybe this is just the ground plane and they left the rest of this open. Maybe that's what's going on. But yeah, it's just, yeah, I just don't see like a resistor, you know, that's what I would have expected. I see the possibility of magic blue smoke. Oh yeah, of course. I don't want to blow this up though. I think we've established that already. Okay, so now let's measure a Raspberry Pi. Or we were gonna do, oh, I was gonna do this. Okay, no, let's do the Raspberry Pi. Stab the film and check continuity. No. No. Nope. Okay, so we need to go USB in. Let's get this back out. And this will plug into here. And then this will plug into my power supply, which before we do anything, I'm gonna hit USB so it drops back to 5 volts. Okay, and then we'll hook up the Raspberry Pi, which I brought upstairs with me, a USB-C just for it. So let's plug this into the Joulescope. So we've got voltage in, or power in, power out. And then we'll plug this into the Raspberry Pi. This Raspberry Pi, not that it really matters, but the image right now that it has is a Home Assistant, which I haven't finished setting up, but it'll at least boot and do something. So that should be interesting to look at. Move this over here. And then we want to take, let's let's go to this connection and plug the Joulescope back in. Okay, so that's plugged in, kind of show the Pi. There we go. Let's go back to the laptop. Nope, other way around. I want that. That way, in case the Pi blows up, you guys can see it, and then we'll switch back to me when I start crying. So right now, everything is off, so we're just seeing, let's go a little bit of noise, couple microamps, and I think that's more or less because of the way that this power supply is designed, it's actually pretty lousy at turning off. It doesn't actually go to 0 volts, and that's what we're actually seeing. In fact, in the review video I did for it, I showed how to fix it. So turn that on. I see the meter, the power supply says it's drawing about 400 something milliamps. Let's turn the multimeter on as well as the scope view. Okay, let's do this. I liked this single value thing, because then what we can do is on this one we can say power, and on this one we can do current. And so we can see (200 millivolts peak to peak voltage). Wow, that's kind of a surprise. Yep. Okay, now it's done, must be done booting, and we can see now the Pi is stabilized. That's interesting. There's a blip every so often. So let's actually stop. Add dual. Click. Put that over here. And then click and put this over here. Oh wow, that's like every 2.7 seconds. I have no clue what that is, but that's cool that we can see something is going on every couple of seconds. Do you know how to build protection circuits? I'm gonna say no. Not something that is a forte. If I needed to build protection circuits though, there's 2 companies I would go to look at reference designs and get app notes. Bourns, B-O-U-R-N-S, and Littelfuse, which is actually spelled L-I-T-T-E-L-F-U-S-E. Between those 2, I think we would find what between those 2, that's how I would design a protection type circuit. It's probably Wi-Fi. Yeah, you're right. It's probably Wi-Fi because it's trying, now I think about it, in fact, it won't ever find the Wi-Fi that it's looking for, because when I set this up, I didn't have my router. And so I was using AT&T's router and whatever their default name was, and I've disabled that. So, okay, that's pretty cool. I mean, that's actually a lot more resolution than I was expecting to see. I think there's also, I saw it in the manual and I don't see, oh, here it is. So this is just kind of a minor thing, but I still think it's kind of cool, because if you're trying to characterize a device while it's on battery power, up here it's telling us how much energy that this device has drawn this entire time. And I think that's a really good number to know, because if you're trying to calculate how long a battery will last, or say you want to do a hold-up circuit with capacitors so that when you're switching power supplies, how much energy do you need to store? This would actually give us a good indication of that. Also, the idea that this Pi is drawing 1.8 watt, man. Oh, I just remembered when I did the thermal tools video, I had a Pi image that had a benchmarking tool that could peg the CPU, but I have no idea where that's at, so that's not going to happen. Okay, well, that's pretty cool. Let's try to do the same thing we did with the Arduino. So I'm going to turn it off, give it a couple seconds to chill out. Let's clear the markers. Let's turn it on. Look at that. Okay. And then when it gets to about the middle, I'm going to stop it and zoom in. Okay, so let's zoom this up a little bit. Huh. Oh, wow. So that's really cool. Not what I was expecting. Well, if I ever decided to do a full-on review of this thing, I would definitely pull out, say, like my oscilloscope and my current probe on that and see if the measurements match. But this is interesting how the voltage kind of ramps up and then the current is getting measured and showing this massive peak. And look at this inrush peak. I mean, this is kind of crazy. Well, let's do a marker. I mean, this is showing that when it first turned on, this thing surged or inrushed 4.7 amps. Now, part of that is the inductive path of everything we've got set up. So it's partially that, but the other side of it is just the board just draws a stupid amount of current when it first turns on, which is one reason why crappy power supplies end up giving you a hard time with the Pi, because it's a pretty hungry device. And so the reason this basically looks like it goes up and then comes back to zero is simply because then it's in the milliamp range, right? This is now it's drawing a couple milliamps. And so if we do this, then we can see, oh, look at how it's like chilling out. Yep. Okay. So let's zoom this out a little bit. And so then we get out to here a few seconds later. Oh, click and then move. Zoom this up. And now we see, so the voltage sags a little bit as current comes in. And now the Pi is probably really starting to boot. That's pretty cool. Cool. Pi hungry, yes. Yeah. Okay. Now I do want to try this other device. So is there a USB cable in here? Or did I already take this one out for something else? Yeah, I grabbed it already. Didn't I grab I thought I grabbed one for the camera. I must have forgot. Bummer. Well, that's bummer. What? No, I know I had something in here that has USB micro on it. What was it? Nope. Okay. I really thought I had one, and I just don't see it. Not even in my magic box of stuff. But I want to look at things. Can't look at things if I don't have the cable. What is this? Lightning cable. That's not gonna be any fun because I don't have my phone. I am so prepared, I tell you. It's a good thing I don't make a living doing presentations. I found another USB-A cable. Bah. Bah. You gotta be kidding me, right? Yeah, because like the one box I haven't found yet is my ridiculous box of, here it is, of USB micro cables. All right. It'd be interesting to install a decoupling capacitor to compensate for the inrush. Actually, that's the problem, is the capacitors are probably drawing most of that current because there's nothing to limit their inrush current when they first turn on. And if you think about the the way that a capacitor works is when you apply a voltage, when it's discharged, it looks like a short circuit. And so there is a huge inrush of current as it starts to charge up. And so a capacitor would not actually fix inrush current, it makes it worse. The way you would have to actually fix it is to do something more active, where you have like a transistor in front of the capacitor, or you might be able to do it with a clamping diode. But yeah, it's actually a capacitor would make it work, or make it worse. What would be interesting is, let me look at this before I say this out loud. Yeah, this doesn't even have like really big ceramics on, it has no electrolytics, and it doesn't even have big ceramics. I think that's just the inrush of the board itself. I think all of the ICs, before any of the power management is up and running, just like to suck all the current they can get. But yeah, there's not even like a big ceramic to take out of there. Okay, turn this off. We're gonna swap the Pi out. Let me get you guys over here. So take the USB-C. This is kind of fun, actually. Oh, but I won't be able to program this. So here's a problem. So I wanted to play with the Analog Discovery 2. The problem is I can power it, but I'm not going to be able to program it. And if I can't program it, it's not going to do anything, because this has a Xilinx on it and it gets programmed over USB. So, well, we'll turn it on and see what happens, but we're not going to get a whole lot of useful information, I don't think. Well, let's see, actually. You don't know until you measure. So turn that on. Yeah, it's only drawing like 50 milliamps. And I can't do anything with it because it's connected to there. If we take it apart, I don't have that screwdriver. That's right, because that's not a Phillips. Okay, scratch that one. Let's take a look at, oh, this will be fun. Oh, actually, that would be interesting too. Yeah, what if we could change the what's providing power to the devices? Yeah, okay. Okay, next thing we're going to look at is, this is an edge badge from Adafruit. It's a, I forgot, I think it's a Cortex M4 or an M7, I can't remember, but it's got an OLED, some buttons, some lights, a couple of sensors. So let's plug this in and see what it does. And in fact, well, I wonder even, I don't even know what, I wonder what firmware I have on there. Because I had an NES emulator on it at one point. So let's do, nope, let me go the other way. This way we can see what we're doing. Okay, turn on power. So, oh, and then, that's interesting. It's because it's charging the battery. I was gonna say it's off and it's drawing 160 milliamps. Okay, turn on. CircuitPython is running. It's still only drawing 200 milliamps. Aw. Yeah, okay. It's not able to run whatever program is on there. I think, do I have, let me take a look at, where did I put the Nintendo emulator? I know where it's at. I know what I can do. It won't be as interesting, but because now I think about it, the problem I had was that the only ROM I had available doesn't work. So let's take a, oh, I turned it off, so it lost the drive. So what do we have on here? I have Joulescope. So let me rename this to huh.py, and we will rename Edgescope. Actually, I'll copy and paste it. So this board, let me back up. This board, oh, you can't see it right now, but the board is running, the board I'm looking at is running CircuitPython. And so it shows up as a drive on the computer. And then whenever it sees a file called code.py or py, it will, it basically starts running that Python program. And so at the moment, now it is running, let me switch it over so you can see it. So it's running a program called Edgescope, which all it does is it measures the various sensors on this board. So like I can change it to the accelerometer, if I remember which button does it. Yeah, so as I move this around, the waveform changes. But what we're looking at this for is when we look at so when I shake this, does it draw more current? Not really. I just thought maybe because it had to do different math or something. Interesting. So it's staying right around 140 milliamps. But here's an example of where we can look at the amount of energy that this board is using while it does whatever it is we want it to do. And then we'd get an idea of how long the battery pack would last on it. So that's pretty cool. Okay, that was interesting, I think. It was interesting to me. I just wish I had, I thought it'd be kind of cool to see it like run something more complicated, but I don't see the, I don't remember what I did with, oh, I know what I did. I already deleted it because I realized what was going on. Okay, never mind. Cool, source code available. Yeah, I mean, yeah, this one was written by Tom Anderson. He does a lot of cool things. I used to hang out with him when I lived in San Francisco. But you know, funny you ask about the source code. So the thing is because the board is running, because the board itself is running CircuitPython, which is a embedded version of Python, all we have to do is go and open up the Python file, and we can actually see the code that Tom wrote. Why isn't this scrolling? There we go. So yeah, you know, it's, yeah. Now you do need to know Python, and then you need to understand CircuitPython. But yeah, it's one reason I like CircuitPython on microcontrollers. Is it's really easy to get started. You just write the code. You don't really have to do anything. You don't have to have an IDE or anything. You just write the code in a text editor, hit save, and it starts running. You know, that's pretty cool. Okay, so we looked at the Pi. Can't do anything with the analog discovery because we really need to power it from external, and I don't have the stuff we need to do that. We didn't look at this adapter. It's got a couple of B and C's on it, but I don't know. I don't even know what I could look at that does that. The only other thing we could have done and we didn't is we could have hooked it up to my load, but I don't feel like we'd see anything we haven't seen already. I think seeing the activity on the Raspberry Pi was interesting, and then I also think that seeing the on the Arduino that we could actually see the current change as the LED blinks. I think that's pretty cool. The only other thing I can think of is we could like play around with sleep modes or something, but I'm not really familiar. I haven't done sleep modes, so I don't want to get lost in that, but it would be interesting to do that at some point. Yeah, we're not going to do that tonight. All right, so that is the Joulescope. I just show it off one more time. Look at that, nice big glory shot. So let's think about it from this perspective. What does this do that a multimeter doesn't? Okay, so multimeters are great for generically speaking, a multimeter is more of a DC measurement. Their update rate is literally a couple times per second, like maybe on the order of like 4 to 10, versus the Joulescope, which is sampling at 2 megasamples. So you're getting much finer resolution. It looks like they have a pretty high bit ADC. I saw something in the document that said effective of 32, so it's probably something like a 12 or 16 bit ADC. The dynamic range seems relatively good. I mean, we were able to see stuff in the milliamps and the amps range. I would have liked to, if I had the rest of my equipment set up, I'd like to dive in a little bit deeper, like when we turn on the Raspberry Pi, is that really what's happening or not? But with what we have available right now, it's too hard to evaluate its technical performance, but I'm feeling like I'd like to do that at some point. Like I said, from my day job, I actually have access to a somewhat similar device, but it's probably more precise and more accurate. And so maybe it'd be kind of fun to compare those two just to see if you paid 10 times the price, what kind of performance are we getting? How does this compare to a current ranger or a microcurrent? I don't remember anything about the microcurrent. So, but I remembered looking at one of those a while ago. Is UCurrent just the, okay. Yeah, I thought this was something different. So the UCurrent, the thing about the UCurrent is it's specifically designed for measuring nanoamps, and so it has a very low burden voltage. It's not a all-encompassing measurement tool. For example, you still have to hook that up to something to make the measurement, like you have to hook it up to a multimeter. So in terms of the Joulescope's burden voltage and low current performance, I don't have a great way to evaluate that right now. I know what we could do to evaluate it. Like I've got a LDO circuit where the decoupling capacitor's leakage current is in the nanoamp range. And so we could use that and compare what that looks like with the multimeter and this and get an idea, but don't have that available. So yeah, so in terms of how would it compare to a microcurrent, I can't tell you how well this measures down there, but also they're not a one-to-one comparison. Even if you had one of these guys, you may still need a microcurrent. And then is current ranger actually the same thing as a microcurrent? So I feel like I've looked at that at one point. Okay, so the current ranger has a meter built in. So yeah. So we don't have a good way. Like I said, we don't have a good way right now to make a comparison measurement. But like I said, I'm thinking maybe that's what we could plan to do later on, like in the future, is once I get the rest of my equipment set up, we could do a more technical evaluation of its specs. Tonight, I just wanted to get an idea of what it could actually do. And so I've been dancing around Geek Boy's question on what's my opinion so far. So my opinion so far is it does what it's supposed to do, and it appears to work quite well. So I'm happy with it, but I also would say this is not the kind of tool that is necessary for everybody. So for example, if you're designing an IoT device or something that has to run on battery, this could be a very good tool to help you characterize its performance. I mean, the closest that comes to this to me would be, you would basically have to have an oscilloscope and something like a microcurrent, but then you'd have to have something that can range between nanoamps and amps. And that's a hard piece of equipment to find that can give you decent resolution on both sides of that. So for characterizing the power consumption of a device, this does very well. The only other tools that come to mind at the moment are significantly more expensive than this one. So I think it's a good tool for what it is. And like I said, I've already apologized a couple times, but I'll apologize one more time. When I first saw what the price was, I wasn't thinking in terms of what it is. It's a pretty decent analyzer for current. So where I was starting this comparison is, I wanted to say, well, compared to a multimeter, because I think a lot of us are going to say, well, if I need to measure current, I'll just grab a multimeter and then you're done. So a multimeter is going to be is somewhat of a gross measurement, right? It's relatively slow. It really gives you an RMS. It doesn't really give you a view of what's going on over time. And most multimeters have a ridiculously high burden. On the other hand, they're cheap and easier to work with. So yeah, so I like it. I think if you need a DC analyzer, a DC power analyzer, it's a good option. So they did a good job. I'm glad I bought one. I have no idea. Oh yeah, I know what I'm going to use it for. So when we get those sensor wings built, we'll be able to plug the wing onto a feather board and then measure what the power consumption is going to be when it's awake and when it's asleep, and figure out how long the batteries will last. Cool. So yeah, we won't be able to do that when we get to that part of that project. So, all right. I would totally have that plugged into my bench all the time. Yeah, I'm sort of mad at myself for having this just sitting in the back of my bench. It's like, not that it matters for you guys, but like so in my old bench setup, like literally right underneath where I had my soldering station set up, this has just been sitting there and I never plugged it in. I really wish I had plugged it in sooner. So I'm gonna plug in this digital camera that I have. Let's see what it does. I'm on USB, yes. Turn that on. So it should start charging, because I don't think this has been charged for a while. And so this is showing it's drawing 780 milliamps. So it is definitely charging right now. I don't see the LED on. Oh, it's on. I just missed it. So if I turn the camera on, interesting how the power dropped and then it went back up. Huh. So while it's on, it's drawing less current than when it was off and charging the battery. I didn't really expect that behavior. Oh man, it doesn't have an SD card, so it's probably not going to let us hit record, is it? Nope. Bummer. Okay. What if we go into movie mode? Holy cow. Oh, wow. Yeah, so in movie mode, this thing is drawing twice as much current. So no wonder it heats up and shuts down on me all the time. That's kind of frustrating. Okay, I'm gonna go back to photo, like one of the photo modes, and just verify that it actually drops. Yeah, look at that. That is crazy. Okay, that's really cool. Okay, what was the other thing I was just thinking of? We had it off and turned it back on. Yeah, it's still not gonna let me. I don't know why you're... So what I did there is I turned the flash on so we could actually see what the flash looks like. And so let's stop this. Oh, I keep thinking that's the stop button because it's red. I mean, I guess it's red for record, but yeah. So the flash, when the flash fired, it drew 900 milliamps. Wow. Okay. I'm gonna turn this off. Run this again. And see if it jumps back up to, yeah, check that out. Isn't that crazy? I would have expected, well, I guess it doesn't charge the battery while it's plugged in so that it doesn't heat up. Because one thing, it's a Sony something, an RX100. And one thing that I read in the reviews about it, people don't like, is that it overheats a lot. And so I think that's pretty clear. What it does when you turn it on is it stops charging the battery or trickle charges it. Because, man, that thing is just cooking right now. Well, be careful to quantify this as sleep mode, because it's not really a sleep. It's charging the battery while it's off. So I understand what they're doing, right? Is when you're not doing anything else, draw a bunch of current, charge the battery as fast as you can, that kind of thing. So what happens if we take the battery out? And it basically drops to 0. What about, can I turn it on while the battery's out? Oh, it won't even turn on. Bummer. Wait, what happened? Why did the Joulescope stop measuring data? I wonder what that was about. Huh. So notice a couple things going on. See this pattern? So down here, USB is green, and on my camera, I'm pressing the power button. I wonder what's happening. Because I press the power button and it tries to turn the camera on, and then I think it's like, oh, nope, no battery, shuts itself back off. But it seems to be interfering with the Joulescope. See? Oh, I wonder if it's because it's ranging. So what are the ranges? 1.8 milliamps. So it's probably in the 1.8 milliamp range right now. And then it probably has to range up to 2. So let's just put it to 2 amp and press the button. Okay, so that's what was going on. Is it was changing the current ranges, and that's why we lost the measurements. So what happens if let's stick it to 180 and then turn it on? Yeah, okay. Interesting. And then what happens if we overrange it? This might be the magic blue smoke you guys keep talking about. So it just flatlines. Okay. Now I'm going to increase it and see and press the button again. Okay. So I didn't mess anything up, but it is interesting how the voltage drop is clearly the same, but whatever the shunt resistance that it's using to measure, it definitely overranged or hit the, what's that called? When you hit the full scale, it hit full scale. That's interesting. Okay. Well, that was an unexpected bonus. Man, is there anything else I could measure? This is kind of addicting now. Okay, no, I don't want to unplug that. Oh, darn. Oh, here we go. I got this Wi-Fi adapter. Let's see what that happens when I do that. I guess it won't actually do anything because it doesn't get enumerated or powered on. So yeah. Okay, let me just take a quick peek around the room and see if there's any other USB devices we can plug in. Because I guess the requirement is we need something that plugs into USB, but only uses it for power. Wait a minute, didn't I have another Arduino? But same problem. Yeah. Okay, so that, I wonder if they've got a plate to handle this, because the problem is all of these USB devices. Oh, what happened? I wonder, oh, I didn't even think about this. Right, oh, gosh, silly me. Check this out. So right now I've got this thing hooked up, right? But what I've been using as my power supply is my bench power supply, or my portable power supply, which has a USB output. So what if we plugged it into the computer? I wonder if the data lines, because if I just kind of glance at the board, it looks like there's pass-through. So what if we just, and I think Dr. J even said earlier, what happens when we power it by computer? So let's plug this into my computer, and then we'll start with the analog discovery. And see what that does. What are we tracking here? So we're using a tool called the Joulescope. It is a DC energy analyzer. I'm sorry, a precision DC energy analyzer. And we're just seeing how it works. Okay, so already we can see something different because we're drawing 85 milliamps instead of 50 like we were before. And then let me open up waveforms. And let's go into, I'll just go into scope for the moment. Hit run. Okay, so it is definitely cleared. Awesome. Okay, so this was, let me stop this. So over here on the left, we were idle, and then we loaded the scope image, and now it's drawing like 360 milliamps or something. That's pretty cool. Oh, then what's this about? Oh, it's just the scale. It's like changing by like 4 or 5 milliamps. Okay, that's pretty cool. Let's see, what else does this thing do? I'm trying to think. If we go to the waveform generator, uses a DAC, and I think I can run that and the scope at the same time. So jumps up a little bit. I wonder what this, let's stop this and then look at what is the frequency of these spikes. So 520 milliseconds, huh? I wonder what that's about. Oh, I see it. I know I won't say exact, but I think I know what it is. I don't know what the source of this is, but let's see if I can get this on camera. So if we look ever so slightly, there is an LED inside that's blinking about, I'd call that every 500 milliseconds. So I don't know what it's indicating or why it's blinking, but I wonder if that's what we're actually measuring, those little spikes in the graph. Like, yeah, I think that's what's going on. Now it could be maybe how often that the PC pulls, or maybe it's changing something that often, but it just seems like that's about half a second, and these spikes are at 500 milliseconds. So that seems like that fits, I think. I wonder. So if we stop the scope, does that change anything? So we stop the scope and then the current dropped down a little bit. It looks like it was like, I don't know, 10 milliamps or so. That's pretty neat. And then if we stop the waveform generator, the current drops down significantly and that LED is still blinking about that rate. And let's do one more check just to see how crazy that might be. So if we put our cursor at the top of one of the peaks, I guess we want let me clear these. I want one cursor, click, hit. So I think this is 372 milliamps, and then down here is 369. So up here, 372. So it's like, right, 3 or 4 milliamps. That's pretty cool. So even though the device is in total drawing 375 milliamps while it's running, we can see the 3 milliamps of whenever that LED turns on. I mean, I think that could be potentially useful. I mean, that's finding that interesting. Enable the P and R. Okay, P is going to be power. So, and then what's R? R is current range. Okay, so if let's do this. Let's run this. And then, oh, see, it's still, okay. And then I'm going to close waveforms. And so that should cause the output to drop. All right, and then the LED stopped blinking too. So now we'll load waveforms. Okay, and it looks like, I think what this is saying on the current range, I think that might just be which range level that we're at. And so I don't think it's changed the level. And I'm not really sure there's anything we're gonna be able to do to cause it to change levels. Oh, where'd it go? Where'd it go? Wow, look at all that noise. So the spectrum analyzer on the analog discovery is basically just doing an FFT of the scope signals. So I wonder what generates all that noise. Let's try, let's go to the pattern generator. Okay. Let me do this and then I'll do that. No, Dr. J. So patterns. Wait, no, this isn't the generator. This is, or is it? Ugh, never mind. I don't want to do that. I thought it'd have like a, so let's kill these. I'm going to turn voltage off as well. And then what's in NI0 and N1. Oh, you know what? I think I know what that is. Let me take a look at something. Yeah, so on the, where is this at? Sorry, it's going to be upside down. I'm not going to turn this around. But on the top here, oh, come on, why don't you focus? Be a nice camera. Focus for me, would you? What the heck are you focusing on? Okay, so there's these GPIO pins, and so N0 and N1 are two of the pins on here. So I think, I don't know if they're analog or they're digital, but it would just give us a couple other channels to look at. I could see that being useful, like if you had, maybe if you had like a signal in your, so let's say you're analyzing the power of a device, and whenever a certain function runs, you might turn on a bit like on an I/O pin so that you can tell, so we can see in the analyzer when a certain function is running, so that we could see how much current that different functions draw. So my guess is that's what that's used for. That's my, that's my guess, but that's also offhand, that's how I would use it. So, okay. Cool. Well, I think that's kind of interesting to be able to see all that stuff going on. Now I'm like rethinking it. What's everything that I can, what else can I program? Oh, now we can do the Wi-Fi thing. Yeah, because this computer's not streaming. Nope, don't care. Let's plug this in. Oh, did I? You know what? I wasn't even thinking. I closed the Joulescope. There we go. So I'm going to unplug the Wi-Fi and then plug in the Wi-Fi. And then let's kill these signals because they're not telling us anything. Yeah, okay. So it came on, and then I'll bet that's about every 2 seconds. And, no, then it stopped. Where is managed network? Nope, nope, nope. Where do you set up, which of the dozen different places that you can change adapter settings do you change adapter settings? Let's try connect. I'm going to connect to my other Wi-Fi. Okay. I was hoping for something more dramatic, but still, the fact that this is, so just having this USB Wi-Fi device attached, and it's drawing almost 500 milliwatts. I mean, that's not insignificant. That's like a real amount of power. Let's change the power here to maximum. And that way we can kind of see what its peak power. Wow, when it peaks at like 1.3 watts. I thought I said maximum. Why is it going down? That's kind of silly. That's not what I guess we could turn on this, and this would give us a decent idea. And we could turn on power. And then this gives us an idea. So it's peaking around 1.4 watts. Interesting. So it's going from 500 milliwatts up to 1.4 watts. Gosh darn it. Now I wish I had an ESP32. Oh, man. Okay, I'm going to have to just do a video on this. This is kind of fun. You know, just to be able to look at and see what devices are drawing, to be able to see it so easily without, like, I mean, even an oscilloscope. I mean, a scope would be an oscilloscope with a current probe would be pretty easy, but it's big and clunky and expensive. Whereas this thing is just a nice little small box, and yeah, I think what would be interesting is to do some tests to get an idea of how accurate it actually is, and maybe like I said, benchmark it to maybe a more expensive instrument. I always like to think about it like these hobby things in terms of that. So like I have a Nano VNA. And I did some comparisons to my actual network analyzer, and it's like, okay, well, there's orders of magnitude and difference in cost, but it gives me a good feel for you know, a lower cost instrument. What should I expect out of it? And so I want to do the same thing with this. So that's pretty cool. All right, can you guys think of anything else we could try? You know, I'm really limited on what I have available. Let me think. Do I have anything I can plug this into? I have this USB capture device. I've always wanted to know how much it draws, but the only other HDMI thing I have is my laptop, and then you won't be able to see what it's doing. Wow. Wow, wow, wow. How do we clear this? I guess we could just run and go. Can we measure your load? Yeah. The problem I have with the load is I don't have a good way to do a load step. I can't do like, say, 10 milliamps and then step to 1 amp, because I can only set one current and then turn it on or off. So if you want to see a load step, then I can't do that. But we could just hook it up and see how we could actually look at the ramp, and well, okay, let's do it, because I actually know I have an expectation for what it, oh, you know what? We can't do the load. I can't do the load tonight because I don't have enough cables, and I don't want to use my other ones. Because I don't have a good way to plug them in. Yeah. But I know where you're going, Geek Boy. So what we ought to do is like have like we could, I could get out later on, not tonight, I could get out my MOSFET board, and we could use the MOSFET and do a kind of like a load step with that to see, because I know how fast that should switch. So we could see how fast it switches on the board. You should do a video about the Nano VNA. Yeah, I mean, what I'm planning to do on the Nano VNA, I'm not going to do like a tutorial on how to use it, but I've been wanting to do a stream about this, and I decided to wait until after I move. So now it's a matter of I've got to find all the equipment in whatever box it's in. But what I want to do on the Nano VNA is compare it to a real VNA and just help people to understand what its accuracy and limitations are, but also understand what you're getting for $80, because I think some people rely a little too much on the numbers it gives, but I also think that for the price, the numbers it gives are really good. It's just I've seen on forums where people are super excited because they say, oh, well, my SWR is exactly 1.2 at 4.7156831 megahertz. It's like, nope, it's not that accurate. So, but it's pretty good. So, yeah. So what I want to say is it's really good for the price, but I want to set some expectations that it's not, you have to be careful with how accurate. It's sort of like if you have a $10 multimeter and you measure a battery and it measures 1.378 volts. It wouldn't have that many digits. If it measures 1.37 volts, it's probably 1.4, right? And so it's still a good number, it's still a good measurement, but the accuracy and the precision, well, in this case, we're talking accuracy, isn't quite there. But for $10, it told you close enough. So anyway, that's my goal, is to make a comparison between the two. I've also been wanting to, I'll just leave it at that. But yeah, I mean, it is a good tool, and I think they are fantastic for the price, as long as you understand what you're getting for that price. And that's all I want to, that's what I want to be able to cover with it, is what are some realistic expectations, and then I would like to do a couple of things where it's like, let me just show you how I would use it to make some measurements, because actually I have to, Geek Boy over on Geek Boy in the AddOhms Discord, as well as he's on chat right now, has helped me quite a bit to get the best out of the Nano VNA. So by the way, I'm just going to do this one. if you want to keep the conversation going, we do have a Discord. So if you go to AddOhms.com/Discord, that will actually bounce you over to the Discord server. And then we can keep up there. As Geek Boy already kind of mentioned, I'll probably make future measurements with the Joulescope, and then I'll end up posting them there. But just wanted to throw that in there because, hey, that's a good place to, thank you, sir. Good place to keep conversation going. So, okay. That was a really long way for me to say I plan to do some stuff on the Nano VNA. Just as a quick, actually, let me just do a little philosophical thing. So for those of you who know me through AddOhms on YouTube, I haven't posted a recorded video in over 2 years now. And it's because for the past year, I've been doing work for Element 14. And so I have a video series over there that I've been working on. And so part of my problem had been in my old house, I had my workbench and that was it. That's where I did any of my electronics work. It's where I shot my videos. It's where I did live streams. And so I really was limited to doing one activity at a time. In my new place, I'll be able to keep like a live stream setup and an Element 14 setup at all times. So I'm very optimistic optimistically, I'm going to get back to doing AddOhms videos in the very near term future. Before all of the COVID stuff happened, I had planned to hire an editor to help. And now that all that happened, that's been definitely put on hold until things kind of calm down. But that was my goal, was actually by this point in the year, I had wanted to have an editor on board so that a lot of the time I spend editing could be offloaded to somebody else. So that said, I just wanted to mention that things like the Nano VNA, which I probably wouldn't cover on the other channel, I would like to do stuff like that on AddOhms, and I've got plans to do so. The really good news is I've already got a couple scripts either completely written or outlined. So I'm ready to move forward. I just haven't been able to yet. So stay tuned. Okie dokie. I'm going to wrap up at this point. I want to thank everybody in the chat tonight. I actually had a lot of fun checking out this Joulescope. Like I said, I sort of wish I had opened it up sooner because I could have actually been using it for the past couple of months. I understand it is not for everybody, but if you are developing an IoT device or a battery powered device, or you're in a situation where you need to literally, like the box says, analyze power usage, a DC power usage, it seems like it's a really good tool. We didn't really get into the accuracy side of the tool, but maybe that's something that we can do in the future, or maybe it's a video I can do at some other point. I just don't have the stuff set up for it. I already mentioned the Discord, so if you'd like to keep in touch, head over to the Discord. I will be streaming again on Sunday. This will be, so based in the Central Time Zone, it'll be Sunday morning. I had a topic in mind and now I've already forgotten it. So tune in Sunday to find out what that is. Oh, silly me. I do want to say thank you for everybody that joins these streams. You know, well, I'll say we, because I think you as the audience are part of what we're doing. We've been doing them for the last couple of weeks through the situation that's going on. And I, number one, want to say, so a couple things I want to say. Number one, please be safe. Be safe, stay safe. Number two, I want to say thank you, because part of the reason I started doing these streams 3 times a week was I needed something to do at night since I wasn't traveling anymore. And so I very much appreciate getting to hang out with you guys, finally cross a bunch of projects and things I wanted to do on my to-do list, finally getting those taken care of. And so I hope you're learning something along the way. I super appreciate all the feedback I get from you guys. And then the last thing I just wanted to say, especially the last couple of weeks, there's all kinds of crazy shit going on in the world right now. I do have a request. It doesn't have to be right now, and you don't have to say anything out loud or send a message or anything. I would just like everybody to spend a minute at some point in the very near future, no more than or as much time as you want, but I'm just saying like up to a minute, and think about something positive going on in your life and something that you're grateful for and something that you're happy about. Because I think with a lot of the stuff going on, it's really easy to say, it's really easy to get down, but let's stop, pause, and think about something that's positive and that we're happy about. My example would be is I'm happy I get to share this this time with you guys, and I get to spend time working on electronic stuff. Doesn't change the world, but it changes my world. And so I'd like you to think about something that changes the world for you. With that said, I'm going to take a quick look and see who is on the Twitch and see if there's anyone doing some cool, oh, that's the wrong computer. Let's see if there's anyone doing any cool science stuff. If not, I'll pop up in the Discord in a little bit if you want to head over to the Discord and chat and say, hey, what's going on? But I'm going to take a break and get a beer and probably get something to eat. She is coding. What is SendShop doing? SendShop doing? Samtech. Man, there's a bunch of interesting things going on tonight. Maybe we should keep going. No, I'm getting tired. So she does Unity game development. Man, why is this so slow? Oh, shoot. Did I leave this? What are they talking about? Okay, this is somebody that's new for me, but I'm going to send you over to this guy. I just came across him the other day. His name is Happy Little PCBs, and it looks like he's doing some 3D modeling with what is that, Fusion for a Samtech connector. So we'll go say hello to him. So again, I want to say thank you to everybody. Thanks for stopping by. Oh, gosh, that's the wrong computer. When you get over to Happy Little PCBs, tell them that I said hello. Happy Little PCBs. And we'll see you guys later. 3, 6, 5, 4, 3, 2, 1. All right. See you guys. And then over here, we're going to go to this so I can close it out for the YouTubes.